All right, here's 6-3, day 2. We are going to put together the unit circle, and we're going to use it a little bit. You're going to see a couple slides in here that are kind of like introductory pages to kind of get to the unit circle, because once we get to the kind of stuff we'll do in day 2 of 6.3, it's kind of like we already have the unit circle. So it's almost like there's the first 3 slides are like prep work. This would be just a reference from a previous page and notes you've already taken, okay? Basically what's going on here is we kind of get in this position as we're like finding a trig value of any angle. We've seen a couple cases where we're like, if we know the point that forms the terminal side, like we saw previously, look at that notes example in your notes where the point -3, -7 form the terminal side, then we can get exact trig values. Okay, other times we go to the calculator and we get an approximation. Without that process of like constructing the angle, because we already have it, the unit circle is kind of like this collection of angles that are typically multiples of 30 and 45, where we have exact trig values. Okay, and that's kind of what the unit circle represents, okay, as we can get their exact values and don't need to use a decimal approximation. I'm just showing you this because we basically start off of all these values. That's kind of how the process works. When I jump into this next slide, these are all the values I'm kind of referring to, okay? So when we get to a unit circle, okay, keep this in mind. It's a circle, right? And its radius is 1, okay? Now, something kind of interesting happens when we do that. I'm kind of covering up my pi over 6 here. I didn't mean to do that, but oh well. There's a right angle right there, right? So if I were to think about this coordinate point, that side would be its x value. That would be its y value. And in fact, as far as marking r, this is showing multiple radii. That right there would also be 1. Okay, in fact, that's probably a better one to go off of, is because this is the same x, y, and r that we defined all the different trig functions, okay? Now, if we think about that right triangle and the fact if we're going to say r is 1, something interesting kind of happens, all right? Let's say I'm going to take that angle's cosine value. And again, think back to those definitions of like, for cosine, x over r, right? That would be the... and I'm thinking of this point right here, right? And that would literally be that length right there, okay? X over r. Well, wait a minute. On a unit circle, r is 1. X over 1, or just x, okay? If I were to look at a sine value of an angle, you'd have y over r. But as always on the unit circle, r is 1. Okay, so what that means is if I think about plotting a point, right? Literally the coordinates of that point, its x-coordinate is the cosine value of our angle, and the y-coordinate is the sine value of our angle, right? Really big point right there. On a unit circle, the radius is always equal to 1. Yeah, that's where it takes its name, right? Think of a unit, or like one single thing, right? In this case, a radius with a length of 1, and a circle that follows. Okay, that's the unit circle. You'll see this. I've already got it marked here. Whoops. These angles... Okay, we can define them in degrees or radians, right? Which is what I just did. All those angles, I've got them on there. So if I were to think of 30 degrees, right? I'm going to run out of room here. But its x-coordinate of that point marked on the unit circle would be sine, whoops, I don't need to talk about theta anymore. It's not an arbitrary angle, I'm talking 30 degrees. Now, this is why that list came up on the other page, okay, that we were looking at these values. So we're talking about the ordered pair, that the x-coordinate is the square root of 3 over 2, and the y is 1/2, right? So this point right there, I'm going to label it right here. If I were to plot that point, it's square root 3 over 2 and 1/2, okay? Tremendous amount of meaning in that statement here on the trig side, right? That x-coordinate isn't just how far to go to the right to plot that point. It's the cosine value of a 30-degree angle. 1/2 isn't just the y value, right? And again, I'm talking right here. X, y, right? Remember r right here, which essentially like the hypotenuse of that triangle has a length of 1, okay? So if we go back to that list that I saw on the previous page, that's why we started with it and we went to 45 degrees, this point right here, its location is square root 2 over 2. And over here at 60 degrees, cosine value is 1/2. Sine value is square root 3 over 2. Okay? All right. And again, those, you can think of those as like ordered pairs, that like the, you know, if this circle that you're seeing, on the next slide I'm going to show you the full circle, so it'll kind of make more sense to think of it as a radius of 1. But that point right there, its coordinates are square root 2 for x and y, and this point right here, its x coordinate is 1/2, y coordinate is square root 3 over 2. Okay? That's a look at quadrant 1. Let's bring on the other 3 quadrants, okay? So now I kind of filled in everything, okay? Because like I told you, this kind of looks like a mess, and if you need to like pause and kind of get caught up, feel free to do that, okay? I kind of have written in all the stuff we already know. All right, I told you this we're going to go all the way around the unit circle, and it's really all about multiples of 30 degrees and 45, okay? And as far as like the sine and cosine values, I already filled in quadrant number 1, okay? But here's what you got to keep in mind. From here, it's just a pattern, okay? And it's going to involve a pattern of positives and negatives. Everything kind of revolves around quadrant 1. For example, 60 degrees to 120, okay? That's a reflection over the y-axis. So I'm going to go to 120 degrees right now. I'm going to have the same x and y coordinate of 1/2 and square root 3 over 2. But at 120, because I'm in quadrant number 2, all that happens is that becomes negative, okay? Because it was a reflection of 60 degrees. Think of 45 degrees reflecting over to 135. Relative to their quadrants, they're basically in the same place. So I'm like, all right, 135 degrees, going to have a cosine value of that, sine value of that, but wait a minute. I'm in quadrant number 2. You're going to see this theme that in that quadrant, all of the cosine values, or in this case, x coordinates, those all have to be negative. How about 150? Okay, that would come from reflecting 30 degrees. Square root 3 over 2 and 1/2. But of course, okay, make that negative square root 3 over 2. Okay, so here's 210, right? This is going to come from reflecting 150. But now we're in quadrant 3, right? everything is negative down here. 225, negative, negative. Right? 240, this would come from reflecting 120, right? 1/2, square root 3 over 2, negative, negative, right? I already put in the quadrant points, 0 degrees, 90 degrees, 180, and 270. Those are kind of funky. That just think about like plotting that point, because they really kind of don't form a triangle, right? So if I were to think about 90 degrees, like right here, to get to that point, my x is 0, my y is 1. All right, same for 0, 180, and 270. Guys, all we have left is quadrant 4. Got 3 more to plug in here. Okay. 300 degrees, that's going to come from reflecting 240, right? They're kind of in the same spot, quadrant 3 to quadrant 4, 1/2 square root 3 over 2. And now I think to myself, what's going on in quadrant 4 with coordinate points? X is positive, y is negative. That came from reflecting 225. For 330, I'll reflect 210, positive, x coordinate, negative, y coordinate. Okay? That's the unit circle. All right? Looks like a little bit of a mess. But the angles, again, if we're talking degrees, right? It's multiples of 30 and 45, right? Really, then if you want to talk radians, multiples of pi over 6 and pi over 4, okay? All the radian conversions are on there too, all right? Hopefully you saw those. They're in red. Of course you saw them. They're right there in the middle, right? Hopefully you noticed them, took notice of them. And yeah, and then all those different, but you're, with all these different trig values for sine and cosine, it's like 1/2 square root 2 over 2, square root 3 over 2, and it's just reflecting and changing the sign from positive to negative. All right, so now I'm actually saying legit, okay? We're in 6-3 day 2. We now have our unit circle, right? It took me kind of 3 slides to say this is our intro. We'll build into it, okay? I want all 6 trig values for 225 degrees, okay? So I'm saying we are right here. Some of them you can get kind of quick, some of them you can't, okay? Now I'm going to say this equals theta just because I don't want to have to keep writing 225 over again, but I should have an angle. So I'm kind of I'm just saying, all right, 225 is theta, so now I can just say sine of theta, right? Call me lazy, right? I don't want to write 225 6 times over, okay? Okay, sine would be the y coordinate. That's negative square root 2 over 2. Cosine would be the x coordinate, negative square root 2 over 2. Tangent negative square root 2 over negative square root 2. That would be a little bit of a mess to simplify, which is fine. You could do that. Or I could recognize it's the same number divided by itself. Therefore, it's 1. I've got cosecant theta, right? So there what I got to do is I got to flip my sine value, okay, which leaves me with a little bit of a mess to clean up here. I got to rationalize this. But wait a minute. Those 2's are going to cancel, and cosecant of 225 is just negative square root 2. Okay. Now I could go ahead and do that work again if I wanted to, or I could recognize, hey, wait a minute, cosine has the same value as sine, right? So if I do the whole flipping and rationalize thing again, just going to get the same thing. Cotangent, right, is y over x. Still, it's still the same pattern. It's the same number divided by itself. okay? So it would be 1. You'll notice as we go through there, sine and cosine are a breeze to get from the unit circle. Tangent, cotangent, you got to, in some order, you got to divide the two coordinates, and then secant and cosecant, you got to flip and then possibly rationalize, okay? Really slick for sine and cosine. It leaves you a little bit of work to do to get the other 4. Not terrible. You can get it pretty quick, but you've got a little simplifying that you got to do, okay? Okay, we'll do, let's see here, 1 in radians. So there we are. Once again, I'm calling it theta, just because I don't want to write 2 pi over 3 over and over again. Sine value, square root 3 over 2, right? I'll go through these pretty quick. If you think you got it, not a bad time to pause, right? See if you can rip through all 6 and then just check your answers with mine. Cosine, -1/2. That's the x-coordinate. Those are the 2 that are just a breeze to get off a unit circle. It's kind of made for us to get those trig values really quick. Tangents y over x, right? Well, there's y. There's x. Okay, so now I've got square root 3 over 2. I'm going to flip that, -2 over 1. 2's cancel, and I get negative square root 3. Okay, that's what I'm saying. Tangent, I don't know, it's not as nice, right? It's not as nice. Cosecant, I'm going to flip sine. And I'm going to rationalize it. 2 square root 3 over 3. That's actually fully simplified at 2 square root 3 over 3. Secant, oh, that's a breeze. Flip -1/2. There you go, -2. Last but not least, cotangent. Couple different approaches I could take. I could do x over y, right? Because tangent's y over x. I could flip it and do x over y, or I could do this, right? I can just take the reciprocal of tangent, right? I got negative square root 3 over 1 for tangent. I can just flip that. Then rationalize it, and I get negative square root 3 over 3. And boom, there's cotangent, okay? 1 in degrees, 1 in radians. Now you've got an example of each. All right, keep grinding away on the unit circle here. I've kind of talked a little bit about something we would call the inverse, okay? The inverse, where you can do that real easy on a unit circle. It's where you have a trig value, and you're like, hey, wait a minute. From that trig value, I want angles, right? Where on the unit circle is sine 1/2. I'm talking degrees right now, okay? This is all just referencing the unit circle. So again, if you see this one and you're like, I got this, right? 30 and 50, they're the y-coordinates 1/2, they're the y-coordinates 1/2. If you feel real confident, pause for these other 5 and then just treat it like me, you know, going through the answers. Like you're getting ready for your homework assignment and preparing to do this stuff on your own with less help than you would get with me taking you through these examples, okay? Cosine of negative square root 2 over 2, that happens at 135, and that happens at 225, okay? Again, keep in mind right now, I'm doing an inverse trig function. You give me a trig value, I'll tell you what angles has those trig values. Tangent of 1, a little bit tougher, right? Because this number isn't listed on the unit circle. I'm looking for where are the x-coordinate and the y-coordinate the exact same thing. That would be here, and that would be here, okay? 45 degrees and 225, okay? Kind of notice it's an interesting little thing as you go through the unit circle and you're finding angles that have these particular trig values, you tend to get 2 answers, okay? You tend to get 2 answers. All right, secant of 2, I don't like that at all, right? But here's the deal. I'm going to use the reciprocal definition to my advantage. what this is really asking me, and I'm going to get my answer in radians now. Where's cosine 1/2? Okay. Where is cosine 1/2? Talking radians now. Pi over 3. 5 pi over 3. Okay. Cosecant. Cosecant equaling negative pi over 2. I'm going to use a reciprocal and get this thing back to sine. This would be 1 over negative square root 2 or negative square root 2 over 2, right? I love to relate things back to sine and cosine because those numbers are directly observable on the unit circle, okay? Where is sine? Negative square root 2 over 2. Looks like 5 pi over 4. I'm looking at the y coordinate now. Looks like 5 pi over 4 and 7 pi over 4. All right, where's cotangent 0? For this one, I don't really think it's going to help to switch it to tangent. I am going to just think about the definition of cotangent, which is x over y. All right, where is that 0? If I think about it as a fraction, this is really all about x. Where is the x coordinate 0? And I look through the whole unit circle and I see 2 spots. That x coordinate takes on a value of 0 at pi over 2. At 3 pi over 2. Okay, therefore, those would be the 2 spots. Cotangent would have a value of 0. All right, the unit circle can also be used for coterminals, okay? It's not just 0 to 360, right? So now I'm back to finding these particular trig values, okay? I'm going to go through, I think it kind of makes the most sense. Let's go through first and just get all the angles switched. And then we'll kind of have a better sense of like, oh, this is, you know, here's the trig value we need to go get. Okay, because that's really what this slide is all about. I'm just going to make sure we're good on space here. Because really, once we have that, there's not a ton to do, right? Here's what I mean on the first one. And let's go do all the angles first. 570, what are you talking about? Well, let's coterminal that, right? Remember, coterminal angles have the terminal and the initial side in the exact same spot. If we're talking degrees, I can add or subtract 360 to my heart's content. Okay? How about cosine of 210 degrees? Okay, how about that? That's what we're after. Okay, now I'm going to keep going with these because once I get it down to an angle that's on the unit circle, I'm pretty convinced I can crush it just like that. Okay, I can get it really quick. I just got to figure out where I'm at. Negative 405. I don't care for that at all. I'm going to add 360. All right. Turns out I'd have to add 360 again, right? But 315. Now I feel pretty good because it's going to be, so it's like if I were to go to 315, that's, right, I see where that is. Negative 405 would just go clockwise, right? It would be going around this way and do a loop all the way around, but I'm going to end back right there, okay? Tangent, I would subtract 360 once. Okay, I'm going to stop showing the work for this one. Just got to subtract 360 once. I'm looking for the tangent of 90 degrees. Okay, so last two in radians, not a problem, right? Not a problem. Negative 2 pi over 3, right? It's still the same deal that we can add 1 revolution around the circle when we're talking radians. We just got to make sure it's 2 pi. And if we have a denominator of 3, we got to switch it to a denominator of 3. Okay? I just need to add it one time. And now I see the question I'm really asking here is that, right? I'm still answering the original question of what is the secant of negative 2 pi over 3. I just know, okay, from using a coterminal, it's the exact same value as secant as 4 pi over 3, which I can see from the unit circle. All right, this one's kind of quirky. 422 pi, you don't want a calculator to help you out with this one. 422 pi over 6, right? Here's the deal. This one we'd have to work at a little bit, but we can get there. We're way, way above 2 pi, right? I want an angle between 0 and 2 pi. So I can subtract 12 pi over 6 to my heart's delight. If you're going to your calculator, what I would do, because you don't need to pay attention to the pi, because that's just going to be there. Your final answer is going to be over 6. That's fine. Start with 422 and just keep subtracting 12 again and again and again and again. Okay, what's going to happen eventually is you'll get to 2 pi over 6. That's your winner. We can reduce it down to pi over 3, right? So it's like as you're subtracting 12 pi over 6, you're just like doing one less revolution, revolution, and we're trying to get, right, between 0 and 2 pi. So here's another way to think about it. With the denominator of 6, as I'm doing this, what I'm looking for is when do I get, if I'm doing 422, minus 12, minus 12, minus 12, when and what number do I get that's between 0 and 12, right? That's the one I want, right? And I get down to 2, right? Because that would put me between 0 and 2 pi. So again, if you took out all those away, the question you're really asking yourself here that's going to be relatable to the unit circle is, what is cotangent of pi over 3? Because that I can look and see. Okay? So remember your coterminals, right? When you expand it with a coterminal, the unit circle tells you a lot more exact trig values than just this handful. Okay? Like cosine of 210, right? Love cosine and sine, right? I can just observe them right on the unit circle, right? I'm just literally reading that number right there. Sine of 315, negative square root 2 over 2. Okay, negative square root 2 over 2. Tangent of 90, right? That is y over x, right? Ooh, we can't divide by 0. This is the first we've seen this. We'll see it again. Both tangent and cotangent from time to time, they can be undefined, right? They don't, there's no number for the tangent of 90 degrees, okay? Secant of 4 pi over 3. Got these last two to go. We're talking radians now, and we got secant and cotangent, but first things first, right? Figure out on the unit circle, where are you? 4 pi over 3. Well, good enough. We're right there. Now you just got to use your reciprocal, right? Secant is the reciprocal of cosine. So I'd look right here at the x-coordinate. Flip that. And there we go. Be negative 2. Okay? Here's pi over 3, right? Cotangent is x over y. I'll do a little keep switch flip. All right, I have to scroll down here to give myself just a little more room. There we go. Twos cancel. 1 over square root 3. Rationalize that, square root 3 over 3. Okay. Can't get it all into view there, but close as I can get, right? So that's just a bunch of examples, right? Understand that all we're after here is for you to see that if you use coterminals, right? Add or subtract 360, add or subtract 2 pi. You can take an angle that's not between 0 and 2 pi or 0 to 360, bring it back to one that's on the unit circle, and you can get any one of its trig values. All right? That's all for 6-3, day 2. Good work. Right? Big step in trigonometry. We've got the unit circle.